Holy fullness. All right. I am not the good version of Jeff. I did not take, I was going to joke and say that there was an evil version of me that had the class for the first few weeks, and I finally escaped where he locked me up, and now I'm here. I just shaved, and it's really weird. Had a beard since about the beginning of COVID, so. But that's the first time in my life I had a beard. But anyway, so it's gone. Maybe I'll bring it back. Let me see. Anybody else have questions? I think there's going to be a decent number of questions from section 2-3. I might just want to kind of go through it at this point.
That's pretty cool.
I think most of us have tried it. So let's take a look here. Where am I at? Where are you? Oh, there you are. Okay. All right. So can everybody see good old section 2-3? Everybody's favorite. So there are a couple things I pointed out that I wish they had done a little bit differently, but I still like this section, and of course I would. I mean, the first thing we talked about is you could tell just from units that these would never work. So we discussed the fact that that's supposed to be 3. And if you look up volume of a sphere, you do get this. Now, there were some assumptions I was making. Does everybody know why the hell there's a 3 there? That's not a part of this formula, is it? What the hell is that 3 doing there?
Is that because there's 3 balls?
Yeah. Each ball has this volume. They each have this volume, and there are 3 of them. So, of course, got to multiply by 3 to see how much volume all 3 occupy. Is that cool? So somebody was worried about that 3. And we discussed this one also. So one thing I wish they would have done differently is they should have focused on these formulas so that these didn't come out of nowhere. So I have a cylinder, and I'm subtracting 3 balls worth of volume from it. That's what this formula is doing. I have a whole cylinder, and in it are 3 tennis balls. So of course, if I subtract those, I'll get the volume left. All this out here, the air. There is all that volume in between the tennis balls, all that volume. That's going to be what I get here. Let me stop for a minute. I call that a cookie cutter problem. Have you guys ever made cookies? You have a big, it's normally not this nice. You have a big sheet of dough, and you put little cookie cutter things in there, and you cut cookies out. So what would the area be? It would be the total area minus the 3 little areas, right? This little area, this little area, this little area. Now it looks like a little, yeah. You with me?
Yeah,
Cookie cutter. So if I cut cookies out of a large sheet of dough, how much area is left? Well, it's the initial area, like the initial volume of the cylinder, minus the 3 cookies I cut out, minus the 3 ball-sized volumes that I cut out. All right. So that's step 1, is to go even a little further than they say. Notice the units don't match, so that's got to be a 3. But then this formula we discussed. In fact, what's pi r squared got to do with the cylinder? What does pi r squared have to do with the shape of a cylinder? Why does that make sense to be there? What's part of the shape of a cylinder? Go ahead, sir.
I thought the square part was due to the fact that we're measuring the...
Pi r squared is the what of the what? What is pi r squared? What formula is that?
Maybe I should keep my mouth shut.
No, you're fine. Pi r squared.
I thought square was the measure of the length of the sphere, no?
So length of sphere doesn't make sense. I think you're thinking about diameter as twice radius, maybe? Diameter is twice the radius, not radius squared. Okay. If I look from above onto the cylinder, what shape do I see?
We see 3.3
No.
centimeters.
I don't see a
A
number. If I
circle.
look at
Circle.
a circle, okay, and what's pi r squared? Related to a
Circle.
circle. What is pi r squared? Didn't we do this? Didn't I do this? I thought for sure I did this, where I cut this
We've
guy
done this,
out,
but some of us were
Volume
not
of a
here,
sphere.
Jeff.
and I did this. So the area of a circle is pi r squared. That's the area of a circle.
Okay.
I like it. Do you
Right.
remember that? Didn't I do this whole thing and we tore it apart and we put it back together and we proved this formula and then we
Yeah.
all said, okay, I'm done with that. I never need that again. But no. Come on. Area of a circle is pi r squared. That's something you need to know. Okay. So that makes sense that that's a part of the volume of a cylinder because that's what the top looks like. And then if I multiply by the height, I just get how many circles I've got. I just add up all these circles. So I got H of those circles. So H of these, that makes the total volume that it goes through.
And the volume is only for dimensional, damn it. What am I trying to say? So I
Not sure.
kind of learned that, go ahead.
The volume is about 3 dimensions. Is that
3 dimensions, and area is just for a flat for one-sided.
flat surface? So 2 dimensions, yeah. And that's why volume
Area
has,
is 2 dimensions?
let me say it. Volume has cubic units and area has square units. And that relates to their dimension, yes. I like it.
All right.
All right. So this first problem was just realizing that's supposed to be a 3. That's all they wanted. And the second problem is to actually do this, just throw this in the calculator with a 3 there. Okay. So several parts to this. So let me do this. Let's do a different kind of problem. I'm gonna stop sharing in a minute. Has anybody got what they need from that? Has everybody got? I don't know if that's even very helpful. We discussed this formula already. We discussed the volume of a cylinder already. And I just want you to see how that's all this says. The volume of the whole can minus the volume of the space taken up by the balls should give you the leftover volume around there. So then if I poured that much sand in the cylinder, it should fill it up completely, right? Or, close to complete. Okay, maybe.
I kind of want to ask questions,
Yes.
but I feel like we're going to take a little longer.
Well, I mean, you could ask a question. I can see if it's something that's leading into where I'm going anyway. Go ahead.
So the volume of a can the volume of the can is 3.3 centimeters, and it's going by 2 to the
Wait.
squares.
Okay, you're all right. You're trying to tear this equation down too much.
Yeah.
Pi r squared, that whole piece, pi r squared, this whole piece is the area of a circle. It's the area of the circle that's right there. And it's repeated all the way down, right?
Yeah. It's repeated.
And then if I multiply by h, which is how many circles are piled up, then I'll get the whole volume that moves through.
I see.
So you don't look at each tiny piece. You got to realize pi r squared is one thing. It's the area of the circle, the base, the area of the base. And then height is multiplied by how much of the base there is. There's h of it. It's the same idea as...
That makes more sense, Jeff.
Okay. It's the same idea as the volume. The area of the base here is length times width. That's the area of the base, right? So how do you get the volume of the whole thing? I do length times width times height, because that's how many length widths there are stacked up. It's the exact same idea. So instead of this piece being length times width, I really want you guys to get this. Stay with me. You ready? Instead of this piece being length times width, because it's a rectangle bottom, now this piece, right, instead of LW, if I have a circular bottom, I'll have pi r squared, because that's the area of a circle. So whatever shape the base is,
Yeah.
that's what's going to go here. And then, of course, is times h, because that's how often it's repeated, times h. Okay, okay. I like it. All right. So I'm going to stop sharing. I want to go up on the board and do a problem real quick.
One more thing, Jeff. I don't want to kill you on this question. I want to save you all for the rest
Kill me.
of the
Can't
questions that
kill
I
me.
have.
What's up?
But
Go ahead.
I was thinking, so 3.3 centimeters, it was times 2 squares because of the top and the bottom. That's what I was thinking. But
No. Yeah,
you
no.
made sense now. You made sense. That's the circle.
Area by itself needs to be squared units, right?
Okay.
Never means because there's some other side. No, it has to be square. So that in itself is the area of a circle.
Just 2 dimensions.
Yes. Okay. I'm going to stop sharing this. Hopefully you all got what you need from it, especially Mr.
Yes.
Robot Cookie Man here. All right. So what I want to do, well, first off, let me spotlight myself because I'm special. All right. Take away this. So let me see. Can you guys see this all right? Yeah, roughly. All right. So if I have, whoa, freaky, sudden marker. Okay. What's the area of this?
Length times width.
That's right. And so what would that be?
56.
Yes. Almost right. 56 what?
Inches.
Nope.
56 square. You put
Yes.
inches square.
So,
yeah.
even not even like you lost it on the math, although that should back this up. Area has to always be square units. So you can kind of play it off. If the formula doesn't come out with square units, you did something wrong, right? So that's kind of a check to make sure you've got the right formula and all that stuff, just to make sure your units come out to squared. All right, now watch. What if I cut out 3 squares, and I'll say there, well, I want this to be a little more interesting. Let me make it, yes, sure, Jeff. 2 by 2 inches. So everybody with me? So I cut those out. Cut those out. They're my boring ass cookies, right? Little square cookies that I make because I'm a boring ass math dude. So what's the area of one of these little cookies?
4 inches.
4 inches square.
Okay. So what's the area of all 3 cookies?
4 inches.
You have 3 cookies. One of them is 4 square inches. So all 3 would be how much? All 3 would just be
12.
12.
You got 3 of these. 12 square inches. So how much dough? What's the area of the leftover dough? What's the area of the leftover dough out here?
56 inches square
Yeah,
minus,
what it used to be minus
minus 12 inches square.
the stuff that I cut out.
Square the same, reduce it to 44 inches.
Yeah.
I almost said I like it.
All right, listen. I want you to realize let me hold off for a second. Does this make sense? In fact, it makes so much sense it's scary because in math, subtraction means you lost something. So when I cut a cookie out, I lost something. It makes complete sense why I'm subtracting. And it's what it used to be before I cut anything out minus the amount that I cut out. And why did I have to multiply this by 3? Because I had 3 cuts. Do you guys see how this is the exact same problem, as all the problems in section 2.3? You have a total volume now instead of area, but still. And then you have 3 somethings. So it would be the volume of the total thing minus the volume of the 3 somethings that I took out, that I'm taking up space with, in this case, balls. That would be the volume of empty space left over. It's the same idea, just one dimension up. Volume instead of area. All right. Let me come back to the problem. Okay. Let's see. Oops. So the first one is just making that cube. The second one is just doing this. Throw this whole thing in your calculator, right? And some of you guys left pi. I need you to multiply pi in there so they can round the whole thing to the nearest hundredth. And then this is the one I said they should have done. They should have reversed the order of these two. I wish they would have, because I would find the volume of the can and the volume of the balls, and then I could subtract those. So these really should have been switched, but oh well. So number 3 is really just figuring out each piece of this formula that you did the whole formula for in number 2. Okay. And number 4 is all right. So all this is decently freaky already. Do I still have that problem up there? Yes. All right. So let me show you what number 4 looks like with our 2-dimensional thing. Okay. Everybody, so what percentage of the volume of the can is filled by the tennis ball? So I'm going to say, what percentage of the dough was the cookies? So let me see. That would be the same thing. So let me. I'm going to stop sharing. So what percentage of the dough? What percentage of the whole dough? Holy crap, Jeff. What percentage of the dough that I had did I use for cookies?
Well,
hold on. Let me make sure everybody's with me. The percentage of the total dough. So what goes on the bottom is the total dough. And out of that, what's the cookies? How much area did the cookies take up?
well,
So how do I always set a percentage? It's going to be the part out of the whole. That's what it always is. So if I say, what percentage of my class likes asparagus? What 2 things do I have to know? Well, how many people are in the class? And how many people out of that like asparagus? And then I can set up the ratio. That's how you calculate any percentage of something.
Well, I thought that you count percentages based off like. Never mind.
Go ahead. What?
Well, I had thought, like reading prior to the other lessons, it says that the number, well, it's math is math, right? But I think I just learned the math language. Like, do you use inputs and outputs as your variables? Like, you know how we have lessons?
Sure. But in this problem, there's no real inputs and outputs. It's not a function. It's a single situation. You could define percentage, the inputs to be the part in the whole, And the output would be part divided by whole, if you like that. Sure.
All right.
Yeah.
Can you tell me how you got 56 inches? I was just kind of paused for a minute there.
All right, that should have happened right when we got it, but before I cut these out, what was the total area of this? What's the area of a rectangle?
So you do 8 times 2?
That's 7.
And
And
7.
7 times plus 7, that's it? Plus 7.
Not plus.
So it's 7 times 2 and 8 times 2.
No 2's. So
Right.
before I cut anything out, stop with the 2. What's the what's the area of this? Length times width, right?
30. 30, right?
You're thinking
7.
perimeter. You're thinking perimeter. Perimeter is addition. Area is basically multiplication. So I thought you just said that earlier. Area is length times width. So it would be 8 times 7.
8 times 7.
And that, of course, is 56. Okay. So that's where we got the 56.
All right.
All right.
Something just
So
threw
you
me
gotta be
off,
real
but I'm
careful.
here. I'm listening to your lecture. So
Yeah. So that would be a beautiful place to check your units. So if you added up all the sides and you got 30, which is correct, it would be inch plus inch plus inch plus inch, which is inch. That can't be an area because it's only inch, not inch squared. So you would know right there that you made a mistake.
Right.
Yeah, okay. What was I about to do? Oh yeah. We did this. Well, what is this here now? 12 divided by 56. What is that?
4.6.
No, I think it's
4 point, what is it? 48.
doing it in my head. It looks like it's 4.33.
4 point.
I don't know. I could be wrong. I could
12
always be wrong.
0.21.
5.
214.
Oh yeah,
Yeah.
it's got to be 1 over 4. I'm doing this backwards
Yeah.
in my head. So it's 0.2. What is it?
214.
214. Okay, so 21.4%. I was doing it backwards.
Yeah, I was too.
So
Beth, did you bring on over the exponent when you
do you mean?
divided?
Okay, beautiful. Thank you. Stop. That was my other point to make. What happens with these? What is 2 divided by 2? Yeah, you do, totally. Die. So there's a problem that said, what units do you get on the percentage? Well, percentages cannot have units. They can't.
Okay.
How many people how many people are left-handed? You would do the number of people that are left-handed divided by the total number of people. So people cancels. Percentages can't have units. They will always cancel out. So there's a gimme for that problem, right? In fact, you can see it happen. They cancel. Right? Is everybody with me? That of course is what happens when you have something the same on the top and bottom. They cancel out. Okay.
Wait. And okay. So it's
All right. So let me see. So I think the main thing that's getting people down on this section is it's talking about volumes, but they're just formulas like anything else. And I try to explain why the formulas make sense. You should kind of have a better feel for this is the volume of a cylinder. Let me see. Oh, good. Okay. Yeah, all I got to do is ask. So I saw many problems when I was grading the homework, and somebody was asking me some stuff earlier, and I knew I was going to have to come back and revisit section 2.3. There's nothing wrong with asking the question. Yeah, let me see. So the thing about number 6 is it follows the same idea and uses the same formulas. I just have a different size. I'm not using a tennis ball. I'm using a racquetball now. So I'm still going to use, and I still have a cylinder eventually. So I'm still going to use 4/3 pi r cubed. All this formula cares about is it a sphere? Is it a ball? Then this formula works. That's all it cares about. So now I know the radius, throw that in, I can get that. And how do I get this? Well, now I got 3 of these. And we know that of means multiply. That's kind of cool. Right? Of means multiply. So 3 of these, so it'll be 3 times whatever I get. That'll be the total volume of all 3 racquetballs this time.
So you're
And then just to remind you guys, sorry?
So you're so you do 2.8 centimeters since it's times 3.
Not times 3, don't say that.
No. So
You mean down here?
yeah.
No. So 2.8's got nothing to do with this.
No.
What is 2.8? That is the radius, right?
That's the radius.
And where's that in this formula? It's right there. So to figure
So
out
you
the
would put
volume, I've got to
2.3
put
to the
I've
third
gotta-
power.
I've got to put 2.8 right there. And then I have
2.8.
to-
I'm sorry.
Yeah, and then I have to figure out what the volume is. I have to actually do the formula, right? Gallery equals. Here. I just replace R with the value I know it has. And now I can throw all that in the calculator.
But I had thought you don't do the multiplication first. 2.8 times 3.
Listen. I am not, so real quick, 2 things. This is not 2.8 times 3. What does this mean?
It's 2.8 3 times. Like it's 3.
Yeah, 2.8 times 2.8 times 2.8. I'm not going to make you sit there and do that by hand.
Yeah.
So this formula, you could just throw that in the calculator. That's fine. The thing
Well,
is,
sometimes-
go ahead, sorry.
And this is where I'm confused. So do you divide? I thought the what is it? The order of operations?
All right, listen. If you had to do this by hand, then you're going to have to apply order of operations.
Okay.
Are you going to do this by hand? No.
No.
You're going to put it in the calculator, and your calculator knows order of operations. If you have a scientific calculator or a graphing calculator like you're supposed to, right?
No, don't have it, but we'll get it after this lesson.
Okay.
Yes.
It should have been before this lesson, but
Yes.
better late than never.
Yes.
Yes. Let me think. So this you definitely don't have to do by hand. So, but then somebody would give me an answer for part A with no, and I say, where's your work? And they say, well, you want me to no, I want you to show me what you plugged in the calculator. That's what your work is. Show me what the formula looks like that you plugged in the calculator. So I'm not going to make you do this by hand. That's silly.
Yeah.
But I do want to see what the hell you're doing.
Yeah.
All right, so there's a balance there. There's always some work to show me. At the very least, show me what it is you're putting in the calculator. And then whatever answer you get there, you're going to triple it because I got 3 of these racquetballs. Same thing we did in the first problem, right? The exact same thing we did on the other page. The volume of the can is again going to be this formula because the can is a cylinder.
Can you slow down just a minute? Jeff.
I did. I stopped.
Yeah. So I'm kind of confused what we do with the 4/3 and having the 2.8. Are we calculating, dividing, anything there? Or we're just leaving it as is?
All right. What did I say? And what's the whole discussion we just had about what you need to get?
Just the
No. About what you need to go buy. Or get your
calculating?
hands on. Yeah. And then you just put all of this in it.
All right.
Okay. So we're not doing this by hand. We're
All
going
right.
to put all of this in the calculator. So you would put 4 divided by 3 times pi times 2.8 to the 3rd power. You would put that in. Okay. And then whatever answer you get from that, you're going to put it right here and multiply by 3 because I'm going to have 3 of those.
All right. I guess that
Right?
makes sense.
Okay, okay. This is 1 racquetball. And then if I multiply by 3, that's 3 racquetballs. And of course, I have 3 racquetballs sitting in this cylinder, right? 1, 2, 3. That one is smushed. Somebody sat on my racquetballs. Be quiet. All right. Now, on part C, just like before, the height is 6 times the radius, just like on the first problem. But on the first problem, they did that work for you. This problem, I got to figure out height will be 6 times the radius. And what was the radius again?
But the radius was 3.3. Or we're
No.
going back to
2.8 cubed.
We're doing the problem we're on right now, yeah.
right,
2.8.
Right, 2.8.
Now, why I'm not cubing? Because it's just a
Oh,
height.
not centimeter. Yeah.
It's just a poor little height. It can't have any square or cubic units.
No units. I mean,
Yes, 6
centimeters.
times the radius. That's all the height is. And I need that, of course, for the formula, don't I? So whatever that is, I'm going to put there. And of course, what's going to go right here?
2.8 centimeters.
2.8, yes.
Hmm.
And then you do that formula. That's the volume of the can. And then what are we going to do? We're going to do this. We're going to take the volume of the can minus the volume of the 3 balls. So part D is going to be my answer to part C minus my answer to part B. It's going to be how much total space was there in the can minus how much space do the balls take up. Same thing we did on number 1, except number 1 in that stuff was kind of guided more. Now they're trying to let you do it a little more yourself. But it's the same idea. This is the can volume minus the volume I took up with those racquetballs will give me what empty space is still left in there.
Can you scroll down just like a smidge? I can't see what you're
Without, unfortunately, the way this works, I can't do it without deleting everything. I'm sorry.
Oh,
I'll write it again. I'll scroll up and write it again. But let me make sure everybody's got as much of the scribble as they want.
No, I mean, it makes sense just by paying attention.
It's crazy. All right, I'm going to clear this. Here it goes. Bye, chicken scratch. Okay. So the last thing I wrote was this. Hold on. This is going to be C minus B, because C was the volume of the can and B was the volume of the 3 balls, right? So what I mean by this is the answer you get to part C minus the answer you get to part B. Which if you let it make sense. So I don't blame you guys. You get a little too into the math and you can't step out to see why it makes physical sense.
Yeah.
You need to have both of those happening at the same time with a lot of problems, right? So the amount of space I had in the can itself minus the amount of space the balls take up will of course equal the empty space left, of course. Okay. Maybe. And then this guy, the percentage of the can, so that's going to go on the bottom. The volume of the can will be down here, filled by the racquetball, so it's going to be on top, the volume of the 3 balls. That's how you do a percentage. Percentage of the can, so out of the volume of the can, filled by these. These take up how much out of the volume of the can. You figure out that percentage. And since they have the same shape, the answer should make sense when you compare it to the answer you got on the first set of problems with the tennis balls. Okay.
I think we got it.
And number 7, let me clear this little bit that I've done here. So we got what they want from that? I think so. Okay. Here we go. Number 7, so watch, what is the procedure we've learned now? How do I figure out the percentage of the golf ball box that is filled. So what I need, the percentage of the golf ball box. So what's going to go on the bottom? The volume of what?
The golf ball box.
Yeah, the volume of the box that is filled by the golf ball. So the volume of the balls, 3 balls. So this is going to be the hardest part of this problem because they don't take you step by step. You got to figure this out, which means you need this and this. The volume of the 3 balls, we've done that kind of thing twice already, right? This is going to be 3 times 4/3 pi r cubed. We've done that twice already, 3 balls. And now the radius is 2.2. Right, so that would go.
Turn that into
See, sir, sorry?
saying. No, I was just saying we're just gonna turn. I'm with you.
Okay. And
Turn
then the
radius
volume,
into that.
yeah, the volume of the box, you got to be careful now. This is not a cylinder anymore. What's the
it's a
volume?
box. Square. Yeah.
What is it going to be? I mean,
Square.
what's the formula? Volume of a box. Volume of a big gas box.
Squared. I know that.
No square. No, nothing
Not
square.
square, but
What's the volume of a box? We just did it earlier.
Cubic. Length times width times height.
Yes. So if I have a box, it'll be length times width times height. So why was I doing a different formula earlier? Because I had a circle shape that was repeated. So that's why it was pi r squared
square.
times 8. Now it's length times width times 8. So that's going to be a nicer formula. There's no cylinder on number 7, is there? No cylinder anymore. It's just a box. So part A, we talked about a little bit, but you should be able to tell if there should be more or less empty space. Anyway, okay. All right. Hopefully that helps if you're still working on that or if you have to work on corrections. Okay, I don't hear many questions. You guys okay out there? Okay. Okay, somebody's give me a thumbs up and I don't know. And I can see some of you guys and the rest of you, maybe you're in bed. I don't know. All right.
Jeff, if you go back to it, to the problem that you just did for the golf balls.
Sure.
I know I'm not trying to take too long on each question that I have, so I'm trying to help her. So we have 4/3.
It's the exact same formula we were using earlier. Man,
Yes.
I can't.
And our radius is 2.2 centimeters to the. So the question is, do you make that?
Volume of a ball is 4/3 pi r cubed always. And now I can
Okay,
just
volume
throw it
of the
away.
ball. All right.
Yeah. And good.
Well, no, we need the calculator. You just said that.
Yes.
Yes. There's no point of. Yeah. I kind of get it. So I'm just gonna have to do some problems. On my
Yes. And what's surprising is I'm not sure how you did a lot of the other problems if you don't have access to a calculator.
I wasn't here. I don't
Okay.
know what the heck I turned in, but
All right. All right. All right, guys. Anything else from homework? Like, has anyone tried anything from section 2.4 out yet? That's the one about the conversions.
you said that like for a question for 2.4 for lesson 2 section 4, right? Is that how you
Yeah,
say it?
sure. 2.4 is fine. Go ahead.
We want to
sorry.
make we want to make sure that we're not we don't have like, if we're gonna do the division, we want to make sure that we have, if we're gonna cross out liter, the appropriate math was to make sure that we don't match up liter with liter. If we're trying to cross out liter, we have to switch it and then divide, or can you go over that one more time?
Here, okay.
For question number 1 on lesson 2, section 4.
And which number 1 are you looking at? Are you looking at the homework or are you looking at the?
At the homework, unless we're on, we can look at the book. We can look at
What
the
are you?
book.
What page are you on for number 1? What's the problem say?
Well, I mean, it kind of just threw me off because I did the
I
problem.
don't know which problem you were talking about. What does the problem say that you're looking
Page
at?
196.
196. There you go. All right.
196. It's unit 2.
No, I know. I couldn't tell. There's homework, there's group work, there's other stuff. All right. They kind of give the answer to this one away in the next one. So is this true? If I write this, is this true? Let's see if you guys remember the numbers. Is that a true statement there? Is that a true ratio to make?
What are we looking at?
No,
Why not?
different units.
Oh, okay. That's the whole point though. Let me do this. 1 foot, 12 inches. Is that a valid conversion factor? Is that
Same
Does that
thing.
equal,
Yeah.
okay. Does this
Yes.
equal 1? Yes, because 1 inch is 2.54 centimeters, right?
Okay.
But could I write this as 12 inches over 1 foot? And it still is 1. It still is a valid conversion factor. If I multiply something by it, it's a version of 1. So it doesn't change the value, right? So if I call this a foot or if I call it 12 inches, I'm talking about the same damn thing, right? So if I change units, I should not also change the value of the thing. I shouldn't do that. It still should represent the same length, right? But depending on the situation, I could either use this or I could use this. So in this problem, 1 liter is equivalent to 1,000 milliliters. So that would either be this or this. Those are the 2 ways I could represent that as conversion factor. So a conversion factor.
Jeff, but I
Sorry?
had thought you said that you don't want to divide 450 milliliters with 1,000 millimeters, right?
Exactly. And that's the point of number 2. So number 1 is just write this or this. So that's right. I cannot say anything's wrong about these 2 because they are both valid factors. Now, if I had this problem, there is one of these 2 things that is correct. As far as how to
Well, the one
convert it.
that's correct is on the one on the left side because we're
Yes. Why?
I don't know why.
Because these 2 would do what?
They're gonna cross out. We're gonna divide them.
So I'll be left in liters.
But
So that's the whole thing. That is the beautiful thing about conversions is if you just put the unit you want to get it to kill, to die, you put it across from it, either like this or like this. Then you fill in the numbers and the math is there for you. It's beautiful. You don't have to think, do I divide or multiply here? No, you just set up the conversion, the little grid, and it tells you what to do.
so can you write that answer?
Well, so here it would be 450 milliliters. And then I want to put milliliters down here and liters up here. And then I just have to do what this says. What does this say to do?
To divide.
Yeah, so 450 divided by 1,000, 0.45.
And are you gonna bring over the 1 liter on top of that on top of that answer? 1 over 0.45 liter, or no?
Wait a minute. What's 450 times 1
450.
divided by 1,000 is 0.45. right? So there's no 1 on top of this. This is not on the bottom. This is what I get when I get from 450 divided by 1,000. That's the answer.
Thank you. I mean,
Okay.
I did. Now you show me my mistake. That was my mistake because I tried doing it. I tried doing this homework over the weekend, and
Yeah.
some math threw me off. So that's
Okay.
what I did. I multiplied.
You do something that a lot of people do. You overthink it. You're like, there must be something else to this. What happened to there used to be a fraction here. Where is it? No.
Yeah.
If I do this math, 450 divided by 1,000 is 0.45. I don't have to make it into a fraction because there used to be fraction. None of that shit. This is 0.45. So that's what the math tells me all of this becomes. I don't have to think, okay, I'm supposed to make it look like this now or something. No. I understand that happens because when you're first learning something, you're not sure what to focus on. I get that. But you need to have a little faith in when I set this up and I do the math, I do what the math says to do here,
Yeah.
I'm done at that point. And then I throw the unit that's left alive on there. I like it.
And you're right. I mean, I seen that answer and I, for some odd reason, I just overthought. I did
Yeah.
something extra. But anyways, yeah.
I'm going to clear all this away.
Yeah.
Well, I'm going to make sure it's okay with everybody. All right. Nobody's yelling at me. Okay. And of course, real quick, number 3, what would the units be if I did this? Just tell me what they would be because they're not going to have any meaning. So what would they be? If I did this, what would the units end up being? So let's look at this.
Liters.
And again, I think it's nice that it's hard for you to say because your brain kind of balks at it. But just look at the units. I don't care what the number would be. What's milliliter? What am I doing with those two? They're across from each
Canceling
other.
them out.
No, definitely not. Definitely not. I love you guys. So, let me erase all this. Help me out here real quick. Now watch. Stay with me.
All right.
Why would
You
these
can go
cancel?
straight across.
Why would these cancel out? For sure. Because one is on and the other one's on the.
Top and bottom.
Yes, and top and bottom means what operations? Multiplication and division. So what's the only way things can cancel in mathematics is if there are opposite operations. Now, what is the operation if everything's on the top? Well, what do I do with this and this? Since they're across from each other like this. Say again? Multiply. So I don't give a shit about the number. What's the unit's going to be? Milliliter times milliliter is what?
Per milliliter.
Square milliliter, which means nothing. And then what's going to be on the bottom is for the units?
Liter.
So it's square milliliters per liter, which is bullshit. Which shouldn't surprise us. Nothing magic about that. We just didn't discover a whole new dimension. We just have math that's set up incorrectly, leading to weird bullshit.
Yeah.
Which is beautiful. Then you say, well, the units don't make any sense. I must have put this the wrong way around. It's the math is trying to help you check to make sure that you're doing this right. The units don't come out to anything that makes sense. So you must have set it up wrong.
All right.
I like it. So you need to start looking at this idea as a way to make sure you've got things set up correctly, not one more thing to worry about. No, this is a way to make sure you've got it set it up right.
Yeah. And
okay,
you make sense. All right. That's cool.
Every now, that's all I hope is at least sometimes I want to make sense. Maybe at least 20% of the time, if I make sense, I'm happy. So let's see, real quick. I'm gonna replace number 6 with my own problem, just because I don't want to go back up and remember what the numbers are. So here's my number 6. Convert. Well, actually, I think I remember. It was 0.4. So convert 0.45 liters to gallons. And they tell you this. Don't say anything out loud. Just take a minute. Can you set that up? I'll start it off. So you just got to figure out what goes where here. Don't say anything out loud. Just try it.
Yikes.
So what do you say to yourself? You're given something in a certain unit. So you write that down. Then and you have to be given or be able to find the conversion. Now you just got to say to yourself, where do I put this? Because I don't want this anymore. I want gallons. I want this out of here. I'm done with you, L. Get out. But no, sorry. I had a whole separate thing happening. So where would I put liters so it would cancel? Would I put it up here or down there? Which one? Up here, down there. Up here, down there. Which one?
Down.
The bottom.
Down, of course, because that's the only way these will kill each
The
other.
bottom, right?
And then I put the other unit up top.
So they make that 1 gallon. Okay, let me be quiet.
Yeah, now I know where to put the numbers now. Right?
1
What
gallon,
gallons or
3.7.
liters? It's 1 gallon, 1 gallon.
3.79 on the bottom.
I love it. So now what do I do with 0.45 and
You
3.79?
multiply those two.
Where's 3.79?
On the bottom.
On the bottom. What's it mean when something's
Yeah.
on the bottom?
Yeah.
What operation is that? What operation is that if it's on the bottom?
Division.
Division. I'm going to divide
Yeah.
these two,
Yeah.
right? So if it's on the bottom, I divide. We know that. If it's on the top, I multiply. We know that. So that's what this does. I really want you guys to see. Tell me again real quick. Well, first off, anybody do that? Let's go ahead and finish this out. It's not in your brain. Anybody do that?
0.118, or if you're
Sounds about
rounding, it'd be 0.119.
Oh, I see. Well, okay. So it's got to be 119 what?
1187.
Okay.
Would that be gallons then?
Yeah.
Yes. You could tell. What's the only thing left alive? Gallons. That's the only unit left alive. So of course that's what it's going to be. So you killed the liters and replaced it with gallons. So something I don't think I've adequately explained to you guys yet is if I tell you, so how many inches in a foot again?
Well,
Why is this easy right now? Can anybody tell me without doing a lot of work? Just tell me 36 inches would be how many feet?
3.
You know to divide. You sort of just have an intuitive feel for that. You know to divide. It's units you're used to. So let me ask you this. What if I had 4 feet? How many inches would that be?
48.
48. Do you see how this way I divided and this way I multiplied?
Kind of
Isn't
help
that-
if you know your timetables too.
True. I'm with you. But that's what I'm trying to show you is a problem that I didn't have to set up. I'm either dividing or multiplying, depending on which way I'm going. That is
Right.
all this does for me. Doing this tells me when to divide and when to multiply. That's all it
That's
does.
good. That's
So if the
good.
number ends up down here, I'm supposed to divide. In fact, let's look at this one. Let me write it in a different color, maybe. Okay, what color is this? Let's see. So if I look at this problem, look at that. Yeah, blood red. If I start with 36 inches and I want to go to feet, where would I put inches?
Bottom right.
On the bottom. I love it.
Feet up
They can't-
top.
So what goes where? Where's 12 go here?
12 go on the bottom.
I love it. I
I mean-
love it when someone puts 12 here. That's insane. 12
Yeah.
foot is not an inch. 1 foot is 12 inches. And now what is this
Yeah.
telling me to do?
Divide.
Yeah, do the
Divide, which is exactly what we did. So my point is not that we didn't need it here, so we never need it. No, when things get really funky and they're not nice numbers, like Linnell said, my brain doesn't immediately know to divide or multiply. So doing this for harder problems tells me when do I divide, when do I multiply. That's all that accomplishes.
good.
Okay.
I like it.
All right. I used to say maybe a lot. Maybe. I think I still do sometimes. So students would always joke me about that. All right.
Maybe with your fingers crossed.
Yeah, maybe. All right.
Maybe. Yeah.
So let me clear that.
Nice.
And that's when I do that, by the way, I really don't want anything I do to make you feel like I'm coming like over you. Maybe I
I
explained
take
that.
it like I hope you got it.
I hope you got it, but
Yeah,
it's
yeah.
more like maybe I explained that the right way, or maybe you get what I'm trying to say, right? So I know my job. My job is explaining this shit, and if I don't do that well enough, then you ain't never gonna get it. So that's, I understand that. I'm gonna
Same
clear
ballpark.
all this. Clear all this. Here it goes. Bye, work. All right. All right, so the other part of this was the metric system, and that's the whole King Henry thing, but I don't think that came up too much in the homework, if I'm not mistaken. Anyway.
We
Okay.
look at question 4 of the homework,
Yeah, let me see. Did I miss a question?
page
Something else?
205. One more. Keep going down.
Somebody asked me earlier, I'm sorry. Let me do this. They asked me a lot earlier to do a problem, and now I'm finally caught up to where you were. Are you still? Yeah, you're still. So no, somebody wanted me to go over the first one, so I'll go over the first one, and then I'll go over the fourth one. So the thing is, you're going to have to reference that page 192, right? So page 192, you're going to have to go between that homework and this page. So the first problem is all about, I already forgot what it was.
Kilometers.
Miles to kilometers, yeah. So if you go back to
Miles.
page 192, can you see anything about miles and kilometers? It's right down there. You guys see what I'm circling down there?
Yeah.
Okay, thank you. So 1.61 kilometers in a mile. So that's an important thing to know. So I know that there's 1.61 kilometers in 1 mile. So that's the conversion I'm going to use. So what gets me started? What do I write right here? What gets me started?
$10.
Yeah, I write down what I have to begin with. And then you just think, where's kilometers go? Where's miles go?
Shikes.
Kilometers kilometers go on the bottom
Yes, why?
because you want to cancel those out.
Exactly. If you get that, you get all of this. If you get what he just said, you get the whole thing.
So
Because now I know, where do I put,
You put
yeah,
1 mile on the top,
yes.
and you put the 1.61 down there.
Because
and
what's the
you-
1 point, real quick, Linnell, the 1.61, just for everybody, has to go with the kilometers. So wherever you had to put kilometers, that's going to be where the 1.61 goes. And now, of course, what do I do with those numbers?
Divide.
Divide. Okay, good. That problem, you can do that. Blah. And that'll be, what will the units be on your answer?
Miles.
What's the unit? Sorry?
Miles.
Yes, because that's the units that are left alive, right? They survived. Which is good, because that's what they want me to get, right?
Yeah, that's also the question there.
Yeah. So 2 things you want to do there is make sure that things cancel, and make sure where you end up is what they want. And then the next problem is how many feet. Well, I know you're going to get an answer right here for how many miles. And there is a conversion between miles and feet. And again, you're going to have to go back to that page 192 very often to continue to get more conversions you're going to need. Yeah. One piece is, as always, there's so many things in here that you overthink. Not that you're making a mistake. It's just natural. You're not sure what to focus on. You're not sure where the mathy part of things are if you're not used to doing these problems. So that's just a natural part of things, is to overthink. Okay. That's another thing to get over, right? Real quick, give me a little aside here. Math is just like any damn other thing in the world. You're going to make mistakes. And in fact, this is going to sound kind of weird. You want to make some mistakes because you don't know it. So of course you're going to make mistakes. So what I mean by you want to make mistakes is let yourself make mistakes and be okay with that. Especially when you're doing homework and you're learning. I understand on the quiz and the final, you don't want to make mistakes. I get that. But if you allow yourself to make mistakes, see why it was a mistake, you will understand better what to do correctly is the hope. That's what homework is all about. Okay.
I think the more stressful factor is how much of mistakes do you allow?
Yeah. Yeah.
That's the stressful part.
But I let you make corrections.
Okay.
And the homework is where you want to make mistakes. And I don't mean purposefully make mistakes. I mean, if you're going to make mistakes somewhere, you want to do it in the homework because then you can try to figure out why it was a mistake that you did. All right, so let me clear this. So the other question was number 4, right? Somebody out there? Hello? I think it was number 4 somebody asked about.
Wasn't me, but we can go over it if you don't mind.
Sure, I don't mind.
I keep getting kicked out of my thing. Sorry.
Oh, okay, it's you that keeps ringing my doorbell. Okay.
Yeah, sorry.
Who asked for number 4? Somebody did, right?
I did.
Oh, you did? Okay.
Yes.
So what now? Just look at this. Not even trying to do work yet. Just how many milliliters of fluid did she consume, right? But then they give me 3 things. She had some water, she had some milk, and she had some juice. Are any of them milliliters?
No.
No, shit. So if only they would have given me all these in milliliters, I could have just done, like if I knew she had 3 milliliters of water and 6 milliliters of get out of there. Milliliters of water and 6 milliliters of milk and 9 milliliters of juice. I could have just added them up, right?
18 milliliters, yeah.
Yeah, but they didn't do that, those jackasses. So I've got to, what do I need to go see if I know? I want to convert that to what? Obviously, I want to convert it to milliliters. So do I have a conversion between pints and milliliters?
I think you might have to.
They better. If they didn't give it to me, we're dead.
Well, you could do the triple too, right? You can break it from one to the next.
It could be more than one step. You're right.
Right.
And then I need a conversion between ounces and milliliters. Do you guys see what I'm saying? So if I can convert each of these things to milliliters, then I could just add them up. This one I would do King Henry to. It's 0.5 liters. And you got good old King Henry, died Monday, drinking, get out of there, no, laughing, drinking chocolate milk. The middle one is always the one without any prefix.
Hey, Jeff,
Yes.
how do you calculate milliliters?
No.
All right. That needs to be a lot more specific of a question, but
Well,
this is
for
currently,
example, if I look at the chart,
all right, looking at the chart, help me out. Is everybody looking at the chart, is there a conversion between pints and milliliters?
there's a conversion for
Pints and milliliters.
I don't see it unless I'm blind.
Okay, that's fine. It didn't have to be there, but if it was there, our job would have been a little bit easier. So let me look at it myself in my actual physical book. Here we go.
It's 480 milliliter. The pint.
480. I don't see that.
I don't see it either.
Where do they tell you, or did you just look it up in Google?
Yeah, like a measurement paper. I don't know. Like,
I don't want you using anything else except what they give you so that you can get the full effect of what they're trying to teach you. Because you could just put all this shit in Google. They'll just tell you the answers. I don't want to see any of that shit. So I saw a few people with a little too exact answers. Those, no good. No good. Now, on the other hand, if you're in the real world, of course, use Google. Holy shit. But
Right. But
reasons
in case
all
that I
the-
want to know.
So listen. Do I have a conversion between, let's see.
To milliliters.
Am I going to see it on the test?
You said pints and milliliters?
Yeah.
No.
I can't go from pints to milliliters, can I? I don't see anything on there about that. What do I see going to, anything going to liters? Here, let me show you. I'm going to clear all this mess I've got. I haven't really done anything up here, so I'm just going to clear it and go back and show you. You see 192, right? Yeah.
No, I don't really see that. Oh, one.
So look down here. This is conversions between systems. So that means between America's system and the rest of the world system, right?
Right.
Here's volume. Do you see how I have quarts and liters?
Right.
Like it. And if I can get to liters, I can then get to milliliters easy.